Number 23 is on today's date in my daily assignments. It's on Friday, and it's over to the right, and it tells you it's got problems 19 and 23 on it. And 23 is a hard one because in the denominator, you have the quantity x minus 1 cubed. So you have to actually cube that before you start. And I showed what I expected you to do. I wrote down x minus 1 3 times and FOILed, and then double distributive property again and added like terms. And that problem takes a while. Then at the end of this video, there's a shortcut on how to do binomial expansion is what it's called. It means you can have two terms raised to any power. And I showed Pascal's triangle. You should have seen that in Algebra 2. And there's another thing called the binomial theorem, which you should have seen in Algebra 2 that you could use. And you can use either one. I use Pascal's triangle because I think that one is the easiest. So I am not planning on doing problem 23 again, because again, if you go to today, the video shows you exactly how to do that. So we're going to do 15 and 17 on page 142. And then I will post this stuff, whatever you ask today, I'm going to put on there in Friday's assignment over on the far right. And I'm going to do whatever problems we do in here as well so that everybody else can have a chance to see them. So I got to get my book and open it up. All right, so let me get these two problems topic down. We're going to do 15 and 17. So I'm going to put 15 and 17 up here. And if you have a question before I get done with them, please ask. All right, so this is page 142, and we're going to do number 15. And number 15 says use long division. So we've got x to the 4th plus 5x cubed plus 6x squared, oops, not cube, minus x minus 2 divided by x plus 2. And then we're going to do number 17. I think it was 15 and 17, right? Yes. And number 17, 6x plus 5, 6x plus 5 divided, oops, forgot my division symbol, divided by x plus 1. All right. Okay, so we're going to do long division on both of these, and if you have any questions while I'm doing this. Okay, for your question, you want to, if you're going to do a search on Khan Academy to watch a video and maybe even do some practice problems, you would want to look at long division, polynomial long division, and polynomial synthetic division. And that should get that taken care of. All right, so this is the dividend over here. That's the part on the left is what goes inside the box. So we got x to the 4th plus 5x cubed plus 6x squared minus x minus 2. Now you notice the exponents go down in order, 4, 3, 2, 1, 0. So I don't have to put any zeros in there. And then I got x plus 2, which also goes down by 1, 0. So you ask yourselves a question, what times x gives me x to the 4th? So I hope we all get that would be x cubed. And then I take x cubed times both these numbers. X cubed times x is x to the 4th. X cubed times positive 2 is positive 2x cubed. Now we are going to subtract this whole line. So I recommend you come up and you change the signs because we have to subtract everything in that line. If you don't change all the signs, you'll mess up. The first ones will always cancel. If they don't cancel, you've made a mistake. So 5 minus 2 gives me 3x cubed. And since there's two terms over here, I need to bring down just one term because I need two terms here. If there were 3 terms over here, I'd have to bring down another term, but there's only 2, so I bring down 1 to make 2 terms here, and then ask myself, what times x gives me 3x cubed? So I hope we see that that would be 3x squared. So 3x squared times x is 3x cubed. 3x squared times 2 is 6x squared. And then I subtract both of those. So I go minus, minus, and I get 0. Those cancel out total. So I would bring down the next number, but I need 2 numbers down here. This 0 doesn't even count as a number. I should probably put this in red. So I bring down the minus x, and I'm going to bring down the minus 2 because I need 2 things. Because I got 2 things here, and this 0 is nothing. It's not there. So now I ask myself, what times x gives me negative x? Well, that will be negative 1. So negative 1 times x is negative x. Negative 1 times 2 is negative 2. And again, I have to change all these signs. So I get 0 again. So that is my remainder because there's nothing left to bring down. That's my remainder. So my answer is just this. And I am done with that one. So that one's the perfect factor. This whole thing equals the quantity x plus 2 times that quantity right there. So that one had a remainder of 0. We're going to do this problem unless someone's got a question on number 15. Anybody got a question on 15? Okay, number 17, again, the thing in front of the division symbol is the dividend, and the thing after it is the divisor. And we ask ourselves, what times x gives me 6x? So the answer is 6. So I distribute 6, and I get 6x plus 6. And again, I must change both signs, all the signs. So when I take 5 minus 6, these will always cancel. 5 minus 6 is negative 1. That is my remainder. So you come up here and you can either put plus and put negative 1 on top over x plus 1, or you could bring that minus sign to the front and it would be 6 minus 1 over x plus 1. Now there's going to be a multiple choice problem on the test on Friday. So when you do long division on that, I'm assuming there's going to be long division. They might write it like this, or they might put the minus sign in front. You need to know that a positive and a negative make a minus in front at the fraction bar. So that's those 2 problems. Does anybody, oh, I got another person ready to get in. Does anybody else have any problems you'd like to see? Anything else from page 120, page 133, page 142? Anybody else got a problem they would love to see? And again, I'm going to post these on video, and number 23 has already been done on video first period this morning. So you can, 19 and 23 are on there. And again, I told you I gave you a Pascal's triangle. For the 2.1 part, what should we look up on Khan Academy? Okay, 2.1 is completing the square. 2.1 is completing the square. So you would want to look up completing this quadratic, completing the square, or completing the squares for quadratics. All right, we're going to do page 21 or page 120, number 21. So this is probably a completing the square problem where you find axis of symmetry and all that stuff. So I got to go back in my book here and find page 120. Okay, 21 says, graph a parabola, write the quadratic function in standard form, sketch the graph, identify vertex, axis of symmetry, x-intercept. So number 21 says, 21, f of x equals negative x squared plus, oops, that's the wrong one, x squared minus x oh, there's why you want it, plus 5/4. All right, so we're going to complete the square on this to put it in vertex form. So the first thing you're supposed to do is make the number in front of x squared 1, and it already is. So then you're going to take and you're going to add something to this to complete the square, and you're going to move your 5/4 over, and then you're going to subtract the same thing we add here to complete the square so that it's 0. We add and subtract the same number. So the number in front of the x, the b value, there's a 1 right here. Oops. There's a 1 right here. You don't have to write it, but that's a 1. So you take the number in front, divide it by 2, and square it. Well, this does not reduce. So you got to take a negative times a negative, which is a positive. If you take 1 times 1, you get a 1. If you take 2 times 2, you get a 4. So I add a 4th here, and over here I subtract a 4th. So this is probably hard because it's got a fraction. So right here, these three things is a perfect trinomial square. So the next step is I'm going to make that into a binomial square. Over here, I'm going to add these 5/4 minus 1/4. Well, that is 4/4, which I would write as 1. So 4 over 4 is 1. Over here, you square root x, so you get an x. Sign of the middle is a minus. The square root of 1 is 1. And the square root of 4 is 2. Now, something I haven't told you yet, I don't know if you've noticed this, but this thing in here is always the same thing that goes right there. Even with the sign, the minus sign goes there too. So that might be a shortcut to knowing what goes there. Whatever's inside these parentheses is what goes right here every time. So my vertex, this is the h, and you got to change the sign, so it is a half. This is the k. You don't change the sign, it is 1. There's my vertex. My axis of symmetry, if you do not put x equals, it's wrong. It's x equals whatever this x value is for the vertex. And we are supposed to graph this, so I'm going to come over here. There's 1, 2, 3. Come over here to -1, and we're going to go up here and go 1, 2. And I probably should, it's going to open up because my a is +1. My a is +1, so I'm going to make it go up a little higher because I want to put more than 1 point on here. So my vertex is 1/2 1. So I go over to a half, which is about here, go up to 1, I put a dot. That's my vertex right there. Then and I hope you remember I showed you this the other day. This is your normal rise. So your a value, which is 1, goes here, and then your rises go 1, 3, 5, 7, and each next odd exponent. So you take 1 times 1, and the new rise is over here for this graph. So you rise 1 first. So I go up 1, over 1. So this should be at 1.5 right here. And then up 1 over 1, this should be at -1/2 right there. This should go up at -1/2 because you got to go right and left 1 from the half. And then 1 times 3 is 3. So from this point, I got to go up 1, 2, 3. And then I'm going to go over to 2.5 because I got to go over 1. And then from here, I go up 1, 2, 3. And I go over to -1.5. And that's plenty of points to draw this parabola. Now oops, went a little crazy there, sorry. I can't, come on, go up through that point. There we go. All right, now I didn't draw it in class, and you do not have to draw it in the test, but your axis of symmetry, I'm going to use this machine that helps me out here. Your axis of symmetry is a deal that goes right up through the vertex and cuts that thing in half. So you don't draw that on there, but that's where that's what the axis of symmetry does. It cuts that all in half. Now we're supposed to also get the x-intercepts. Well, look at this black line. Where does the black line cross x? Well, it doesn't. So the x-intercepts are none. Another way you can find that is, you remember up here, this is f of x equals this thing. You can put 0 in here and solve this thing for x. So if you subtract 1 over, you get -1 equals x minus 1/2 squared. Then when you square root both sides, you get this. Well, as soon as I see this, that's Mr. Downing's friend. They're imaginary. That tells me there's no x-intercepts. Does anybody else have any problems you would like me to do? And by the way, if you go back to Canvas, the first day I did all these other problems are still on there for you too. So you can go back and watch those old videos that are on this week and get your questions answered. Does anybody else have anything they would like to ask about anything from 2.1 through 2.3? I am not seeing anything. So I'm not going to keep you if you don't have more questions. Now, let me tell you this, 7th period today, I'm going to do another pre-calc Zoom session, 7th period. And if you go back to my homepage, there at the bottom, it says 7th period Zoom. If you come up, if you try to work some of these out today and you get stuck and can't do something, you can come to 7th period Zoom and ask me to work out a problem that you didn't know you had yet. Okay? And then Monday, I'm going to ask, anybody got any questions on anything before we take the quiz on 2.1 through 2.3? And if you have questions, I'll go over those on Monday before the quiz, and then we'll take the quiz. I'm not sure how long the quiz is, but if it's very long, we probably won't spend much time doing review questions, so it'd be much better to ask now. So this is the last go around. Anybody else got anything? And again, I'm going to post this on Friday's Canvas page as soon as I can get it done. So I guess I don't see anything else coming up. So I hope you guys have a great weekend. Stay out of trouble. Do what's right, not what's popular. And I will see you all on Monday or on Tuesday. So have a great rest of your weekend.